Hello, hello, and welcome to another edition of Spindle TV. I'm your host, Laney Shaughnessy. If you're just joining me for the first time this evening, it's great to meet you. And tonight, we're going to be in the Vectric software, and we're going to be talking about rotary axis, all things rotary axis. Not all things, most things rotary axis. We're going to be creating a rotary job in the Vectric software. We're going to be talking about setup and layout and everything. And then we're going to talk about the different types of post-processors, the different type of machining methods for rotary type jobs. And hopefully through tonight's course, you will gain some information that you might find useful in your particular projects and everything. So what we're going to do to get started is first a big shout out to all of my Spindle TV exclusive members that have joined us tonight. Hopefully y'all are all doing well. And tonight I'm going to be building the model of a table leg. Not necessarily a table leg, we'll call it an island leg or a leg that we would use a piece of furniture. And I'm going to be working in the Vectric Aspire, but the information I'm going to be talking about can be, translated and used with, Desktop and Pro. The only thing that you wouldn't be able to do with Desktop and Pro is make the models, the actual 3D model that we're building. But a lot of the other stuff, as far as dealing with components and drawing vectors and wrapping and things, can be done in Desktop and Pro as well. So what I'm doing is I'm looking at trying to get used to the new look of my layout here. There we go. That's the view I'm used to seeing. There we go. Let's I changed the layout of my computer screen, and probably a mistake before a class not to change anything to make it hard to find. Okay. All right. We might be getting a little technical on some aspects of the software when we're talking about post-processors and the different types and things later on as we get into it. Don't let that deter you or throw you off. It's like one of those things, like when we were all kids and we were in school and the teacher was, teaching fractions or algebra or whatever the case may be. And we looked at the teacher and said, when will we ever use this in life? And then come to find out, right now is the moment. So it's right now. Just kidding. All right, let's see here. Let's switch over to the second screen where my Vectric software is. And let's put me down in the bottom corner. Let's see here. Let's go down here. And let me turn on my mouse pointer so everybody can see where I am on the screen. Good time. All right. So in your Vectric software, when you're working and everything, in the case of this, it's a rotary job. Now, your rotary job may rotate, that spindle turning may rotate around your x-axis, meaning that the length of the spindle runs along the x-axis of your CNC. And when the Y or the A rotate, it's rotating across that x-axis. And for me, the length of my x-axis runs horizontally here on the screen. And so from top to bottom of the screen, imagine it kind of wrapping around. I'm wrapping around my x-axis, but on other CNCs, depending on how your rotary axis is mounted, it could be running the length of the y-axis and wrapping the turning could be rotating around, that y-axis, and it being like your x or your a-axis. And so in your rotary job, when you put in the length of your spindle and you put in the diameter, not your spindle, let me not use the word spindle, your blank. Because this could be a spindle, this could be a table leg, this could be a rolling pin for the kitchen, it could be a statue, it could be anything 360 degrees around, right? So I don't want to use the keyword spindle and any confusion. So our blank could be round to begin with, or it could be a square blank. In my case, it's a square blank. I have a blank that is 6 inches tall by 6 inches wide by 36 inches long, according to my software here. Now, in my particular case, if we look at the measurements of the spindle that I'm working with, the overall length is actually 35 1/4, and the overall dimensions is about 3 3/4 to 4 inches. I'm going to go a little bit bigger. I'm going to go 4 inches. So on my cylinder here, I'm going to put in the exact size of 35 1/4. If my blank is any longer for waste and all that stuff, that's going to be a choice that I have to make. Do I include that waste in the design, or do I account for it at the machine where I measure and make a mark where I'm starting, bearing kind of that waste at the machine and not having it as part of my design? I've taught it both ways. It really depends on what you're wanting to do. And let me see if I can make this a little bit clearer. If my part was 35 inches long in the software, but I allowed for a 1/2 inch of waste on each end at the table, and my blank was actually 36 inches, a 1/2 inch on the front leading end and a 1/2 inch on the tail end, that 36 inches. When I carve, I need to make a measurement a 1/2 inch over on my blank at the table, and I need to zero out my axis, my whatever that length axis is. In this case, it's my x-axis. I need to zero out my x-axis where the bit is centered over that pencil line, and it's going to be carving from that point 35 inches over, right? And so I'll have a 1/2 inch of waste physically at the machine, but I don't have it in my drawing here. I'm not accounting for it in the drawing. So the drawing is only milling that 35 inches. That's all it knows. That's all it cares about. And it's up to me at the table to know that my blank is longer, and I'm just starting in the right spot on that blank so it carves, in the center. Now, if I account for it in my design, then I need to make sure that in my design that I mark and lay out for that 1/2 inch of waste on each end so that my design falls correctly in the drawing, and the ends don't get milled. Because if I'm doing a rounding toolpath, or if I'm milling away, down to a small dowel or something, I don't want to run into my tailstock or my spur drive or my jaw chuck or whatever it is that's holding my part, right? So what I like to do is I like to just make sure my blank is longer, and I'll measure and mark at the table. I don't account for the waste in my design, but it's up to you what you do. So in this case, I'm just going to lay out the 35 1/4 here, and I'm going to go with a 4 inch diameter instead of a 3 3/4. I'm going to go 4 inches because I'd like to have that 4 inch by 4 inch. I'd like to be pretty close to that 4 inches. Now, when it comes to zeroing out the Z, you can zero out touching off on the surface of your blank, or from the center of the rotation axis, of the rotary axis of your blank. And either one you can do, but I will say that you're going to have more accurate results by working off the center of the cylinder for your axis. The center cylinder axis being your zero position, you're going to have more accurate results. If my blank was slightly askew, or if I am touching off on a high spot or a corner or something, I'm not really getting a good consistent touch off or something. If I'm touching off on that surface, and it could pose problems. Not saying that it would, they have it in there for a reason. I mean, you can do either or, but every job that I would ever teach, every job that I train our customers on and everything, you are working off the cylinder axis, because I want you to have the best results and outcomes. So that's what we're going to set up in this job today, cylinder axis. Now the datum is always going to be the bottom left corner. You're not going to be able to work in the center or anything like that, like you're used to with your flat jobs and stuff. If it's a rotary job, it needs to be the bottom left corner in the Vectric software. And let me get the window to pop back up here. Let's get that screen to refresh itself. All right, let's try that again. All right. And so my job setup, Z0 position, cylinder axis. My datum is bottom left corner. The bottom left corner is where we're going to start. And on my machine, my machine's rotary axis rotates around the X. So along the X axis is what my option is going to be. And so the X axis is the full length of my spindle, and either my Y axis or my A axis, depending on how your machine is set up, is the rotation of that cylinder. All right, so I want a very, very high resolution on this, because I'm going to be building a model. And so I'm going to go ahead and click OK on this job setup. And then I'm going to go back into the job setup, but this time I'm going to hold the shift key down when I click on the job setup icon. And that's going to give me 2 additional options in my resolution, model resolution. And I'm going to work in an extremely high resolution, so it's less pixelated and stuff. By default, most times your very high resolution is good. In this case, I'm building a model, so I want a little bit higher resolution, because those the pixelation in your preview, your 3D view and everything, any pixelation in that 3D preview plays a role, and it translates over to the quality of the finished carving. All right. Let's go back here. Now I'm going to get y'all in front of me. Give me just a second to get all the comments and conversation and everything in front of me so I can see them, so I'm not having to look over my shoulder. And I hope everybody's doing well tonight. I'm going to try to make this as fun and creative as possible, not too overly complicated. Almost there. We'll get things rocking and rolling. How many of y'all watch Garrett Fromm and IDC Woodcraft videos and all? Did y'all see Izzy Swan on his channel last night? Oh, Izzy Swan, great guy. Love him to death. All right, let's see here. Let's go to live tonight's class and click on the studio. There we go. All right. Once again, Ziggy M, good morning from Australia. How you doing? Thanks for joining us. Troy and Brooks, Martin, JR, David. I can now see everybody, right? I can see all you. Kool-Aid, how y'all doing tonight? Ronnie Probert, so I can see kind of all the chat popping up in front of me now. All right, so we have here in this job setup, we have basically what you're looking at if you're new to Rotary Access and Rotary setup in Vectric is think of a round paper towel roll, right? Think of taking a knife and slicing down that roll and then just unfolding it into a flat sheet. That's what we're looking at here. This is the circumference of that cylinder sliced and unwrapped into a flat plane. So on our screen, that's what we're looking at right here. So the left to right on my screen, that is my x-axis, and it's 35 1/4. And then the circumference of my part is the height of my computer screen here, the up and down. And for those of you that are curious, 4 times P equals from here to here is 12.56637, right? So 12.566371 to be exact. That's the circumference of that 4 inches unwrapped when you multiply it by pi. When it comes to the software, when we're looking at it in the 3D view, we can either look at it as a flat plane in the preview, or we can turn on the wrapping, which wraps the object into a cylinder, right, when we're previewing it. So that rotary and everything. And for the most part right now, I'm going to be looking at it as a flat plane. In the 2D view, we have our drawing here. And on this drawing, what I'm going to be inspired by tonight as far as the rotary that we're making and everything is if we take a look at this image here. This is not my kitchen by any means. It's an image off the internet. But we have these columns, if you will, these corner columns for this island, and on the bars themselves, we have on the island bar, we have these columns and everything. And this is just a Roman, a braided Roman classical column. And we are going to create something very, very similar to that. So if we were to look at a kind of a dimensional drawing of this part, we have this kind of braided area here in the middle. And that's going to be fun to draw out to show you how that's done and things like that. We've got the upper apron area, which is going to be a square blank, and we have the lower area, which is going to be a square blank. And this is the most interesting part, the upper and the lower on the square blanks, because in the software, generally, one of the very first toolpaths that we create is a rounding toolpath. So if I have a blank that is 4 inches by 4 inches, generally I would do a rounding toolpath that takes that entire blank and it rounds it up, trues it up, gets rid of any defections and everything. And when it's all said and done, out of that 4 inch by 4 inch, if we were to draw a 4 inch by 4 inch square on the screen, and if I were to draw a circle within that square, if I told the software in the wrapping gadget to create a rounding toolpath, it would ask me in the little wizard window, it would ask me if I'm working with a blank that is square or a round blank. In this case, I'd be working with a 4-inch blank. Then it's going to ask me how I would like to mill this, the machining method. And in this case, when milling, I want to remove all 4 corners first. I want to remove all 4 corners first. And then I want to true up and round it up. So that's called the optimized raster. So along the cylinder, it machines off the 4 corners and then it rounds it up. So that would be the what I would want left and everything. Now, I would put in a tool for the rough cut or the rounding tool path, and it could really be anything. I typically use a large diameter bowl and tray bit that has radius corners, also referred to as a radius end mill. It's flat at the bottom and it has radius corners. But you could use any style bit you want, but a roughing and rounding toolpath, I'm going to typically use kind of a somewhat of a large diameter. So if I went into my bits and everything here, I would come into not my surfacing bits. I love when Vectric comes in and hides my tools and my categories, and it's not showing me all my bits right now because it's saying, hey, you can only use this particular type of tool. That's okay. We'll stick with it. So I'll just use my 1/2-inch end mill for my roughing tool. No big deal. But if we were to, when we're out of this tool here, I'll show you my tool database, the bit that I was going to use. But Vectric's like, no, this is all you can choose from. And that's fine. That's cool. That's fine. I can use my 1/2-inch end mill. But here's the deal. If I am starting out with a 4-inch blank, and when it's all said and done, my cylinder diameter, my finished diameter on the true round, I have that as 4 inches, then that means that, I'm assuming that I can get a true 4-inch round out of my 4-inch by 4-inch blank. And that's not going to be the case, because if I do that, I'm going to end up with a flat spot here, here, down here, and over here. We need to account for that somewhere or another. We need to take our cylinder, our finished diameter when we're rounding, and it needs to always be slightly less than our blank. Now I'm going to account for probably about a 1/16 of an inch. And so my finished out of a 4-inch blank, I'm going to probably end up about 3 15/16. That's a 32nd on all 4 sides, a 32nd off the left and right side, not all 4 sides, off the left and the right or the top and the bottom. So 3 15/16, or to give myself a little bit more room, I'm going to go 3 7/8. So I'll give myself a 1/16 of an inch on each side, because you're thinking now 360 degrees around, left side and right side, or top and bottom. When I'm measuring across that diameter, I need to account for it. So technically on here, if I reduce the size to 3.875, okay, that is giving me a 1/16 of an inch of waste that's going to get milled away before it trues up the round at the top of the part. Okay. And at the bottom of the part. Okay. So I have that 1/16 of an inch all the way around, total 1/8 of an inch, right? That's what I want. When I'm rounding this blank and everything, I want it to mill to a true round. So always make your blanks bigger than if this part had to be 4 by 4, no more, no less when it's finished, then my square blank is going to be larger so that it can mill down to that 4 by 4, right? In this case, I can get away with 3 7/8 by 3 7/8 on my blank. No problem. That's fine. But it's not always that case. So if you're like, hey, I've got to have a 4" by 4" apron, whatever the case may be, then my blank needs to be at least an 1/8 inch bigger, 4 1/8 by 4 1/8, before it goes to the machine, before it goes to rounding and all. Now, when it comes to the rounding, what I was talking about just a moment ago, and we kind of led into this, is on my reference image, my apron of the table leg and the base of the leg, they're square, right? So it's kind of crazy that I'm going to be going from a square blank to a round cylinder when it trues it up, back to a square leg. It's actually going to mill a square back into this. It's going to flatten all 4 sides and get that square back. To end up with the size that I want or need and everything, that is the case. Now, if I'm pushing my luck and let's say that on my table leg, the bottom 6 inches and the upper 7 inches, they need to stay square based on what I have mounted in my table. And I'm only milling within, let's say, as an example, this area here, and this needs to stay square blank, that needs to stay square blank, and I can't cut, I'm not able to cut into it, I can't round it off and turn it back to square or whatever the case may be. I just need to leave it alone. Then I need to work within this area, right? I need to have a boundary laid out like this rectangle here. And all of my tool paths, I need to machine within that boundary, right? So the bit doesn't go past that boundary. Okay. That's fine. As long as you define, as long as you lay out, hey, this is where I'm carving. Don't touch this. Carve in here. That's good. That's fine. No problem. Now, in my case, my blank is starting out at 4" by 4. And when it's all said and done and squared back up and everything, we know from the drawing that my actual table leg was 3 3/4, and in this case it's going to be 3 7/8. I still have room if I wanted to go down to 3 3/4. I still got another 1/8 of an inch I can mill off, so I'm good and everything. I don't need to leave a certain area alone. So all of these things you have to kind of be aware of, and you have to think about, and it's like before you even started the design, before you even started the project, it's like, Jesus, holy camole, what in the world? There's like a lot of stuff to think about, which way is it rotating and how much waste, when I round it up and all this stuff. And it can sometimes for people, 4th axis or rotary axis could be intimidating because of that, right? It's like taking a blank and putting it on your lathe. The first thing you do is you round and true up that blank. And then from there, you start milling or turning your project, right? From there and stuff. But most, turners will true up your process. And that's what we're doing here with this rounding toolpath. So this is the critical part. My job setup here needs to reflect the actual finished part. So it's not a 4-inch diameter, it's 3 7/8 inch diameter. That's going to be my finished piece. That's what I'm starting with after all the truing up and the rounding and everything. That first rounding. Now this is not counting when you're carving your statue, how big the statue is going to be around, or the rolling pin or the table leg. It's not that. It's when we take this blank and we true it up. round it up, what are we left with to start milling whatever our project is out of that? And in this case, it's 3 7/8. So when I come in here now, and I come into my gadgets, give it a second to get caught up there. And when I come into my gadgets and my wrapping gadget and create that rounding toolpath, I'm starting with a 4-inch blank. I'm milling the corners off, and then I'm rounding it up using an optimized raster method. I'm using for the tool my 1/2-inch end mill, and I'll select that. And when it's all said and done, down here, my cylinder dimensions, when it's finished rounding up, it's going to round up to 3 7/8. That's what it's finishing up to. Okay. So when I click OK, it is creating that rounding toolpath to see if I can get this to turn like that. It is going to mill off these 4 corners first. So that part, and we're going to talk about layout and everything here in just a second, but that part is going to be, it's going to rotate 45 degrees and mill off that first corner. When it's done, it's going to rotate another, 90 degrees, 40, I think it's 45, but it's going to take off the next corner. It's going to rotate another 45 degrees and take the next corner. It's going to rotate another 45 degrees and take the next corner. And then once all 4 corners are done, then it's going to come in and it's going to, start rounding off and truing up. So what we see in this tool path pattern here, if I tilt it down ever so slightly, is on these blue and red lines that we're looking at that are looking like, whoa, if I unwrap this into a flat plane and everything, the top tool pass and all, it's coming in and milling off this corner, and then it's going to come over and mill off this corner, and that corner, and then it's going to come down to the next level, and it's going to just that back and forth, back and forth, back and forth, and everything. And so that is going to be our rounding toolpath. That's what it looks like when you're looking at it in the preview, right? All those lines and paths, that back and forth motion and everything. So let's get rid of this on the screen here. So that is my first toolpath. Now, the fun part. On my layout, looking at the table leg, if we look down here, 5 3/4 inches up is going to be square, right? And then at the top, that top 10 inches is going to be square. And so I'm going to use my layout lines, my guidelines and everything, and I'm going to come over here and I'm going to create a guideline 10 inches over. And then I'll take another guideline, come down to the bottom and snap it there. And then we'll bring that up 5 3/8. So we'll go 5.375. Now, that is a negative number, negative 5.375, because the guideline is going to the left. That's what we want. So this guideline from the edge, 5 3/8 over. And then from this guideline, 10 inches over. Now, this area in here is where all my decorative ornate stuff is going to happen. The 2 outsides is where I'm going to be milling up my squares. Now, in our tools, in the Vectric software, when it comes to the rotary tools in Vectric Pro and Vectric Aspire, you're going to have a tool. You'll most likely find it under the transform objects area, but it's this circle with two arrows kind of pointing like this. And when you hover your mouse on it, it says unwraps selected object. So it unwraps the selected object. Now, if I come in here and draw a 3 7/8 by 3 7/8 square, and I'll just do it right here on the side. Make sure everybody can see that on the screen. If I draw 3 7/8, 3 7/8 square, imagine, if you will, that I came in here with a pair of scissors and I cut it right in the middle, snip. And then I took that and unwrapped it and everything. And I unfold it. The corners are still going to be there. And between the corners, those flat areas, you know, the flat areas of my four sides, they're going to kind of flex and bend. And so if I take this object and I unwrap it off of the center of that contour and everything, when I click apply, it's going to, let me see here. This tool cannot produce an accurate shape because the modeling plane of your model is not centered on the center. Would you like to correct that automatically before continuing? Yes. Now, what that is telling me that in my job setup, let's go back over here in my job setup, the model, my part here and all, has the cylinder center and everything. It was in kind of this location and all right here. And when I came in to create that contour, let me come in and I'm going to delete it. We'll come back and show you what that shape looks like. When I came in here and I applied that, my part was in the wrong position. It wasn't in the center. So on my cylinder axis, it was probably up here or down here or somewhere in there instead of being in the middle, you know, for my cylinder axis. So it wasn't creating that part properly. That's what it was just letting me know that. And it said it couldn't create the contour because my model position in the material was not centered properly. Would I like to correct that before I continue? I clicked yes. That's all it was. All right. So, and so what we have here is, if we take this, let's close this tool, or that little circle is going to be following everywhere. Let's bring that out here on the screen. And if we look, what we see here is these 4 points on this shape that got drawn or created. That's the 4 points of our rectangle, or our square, not our rectangle. And in between these curves right here, that's our flat faces. That's this face, this face, this face, and this face. If I'm taking that and forcefully flattening it out and those corners are kind of folding up, then when I bring this into a flat plane, the space in the middle, that flat area, is kind of curving inward. You know, it's creating kind of a U. And that's what's happening here. And it's what's, you know, kind of occurring. Now, if I were to wrap this back up into a square, I would basically be in, if I go into node editing mode, if I came in and let me cut that for just a moment. I'm going to cut that. And that. And that. If I came in and turned this into a line in here, so getting rid of those points, and I rotated this part around, kind of, let's say here, and I cut that. I zoom in and select that and hit the letter Y, and I straighten that out, and I take this, turn that into a line, and bring that around and align this to bear with me here. And I turn this into a line. I'm stretching this by all means, so bear with me. But that's coming there. This would turn back into a flat line, and it would swing up here. I'm shortening things, but this, if we bring that up to here and rotate that bad boy, I had to find my rotate tool, wrap that around. Bear with me. It's wanting to argue with me, but it's hard to unwrap and wrap manually. That's why I love the tool. But let's see here. Let's delete that, and let's take all of this. That comes down here. All of this would move there. I think you probably will get it, but I'm trying to emulate where it started or how it started, right? So let's select that, hold down the shift key, select that, hit Y. Let's select this, hold down the shift key and select that and that, and hit X. Turn that into a line. And I think you get the point. We can waste all time and all, but it starts off as a square. So basically when it unwraps, it creates that hump and wave, if you will. All right. That was a lot of just nothing, but just trying to kind of explain that. But at least you maybe get the gist. All right. So we're going to unwrap this. Let's come in here and unwrap that on the center of itself and click apply. And that creates that part here. Now, this is the part that's going to sweep in this area here and in this area here. So on my rails here and here, when I'm looking at this part in the 3D view, let's turn off that toolpath and all, and I come and I wrap this up right here, right? It's a round cylinder right now, right? That's how it's previewing, as a round cylinder, because it just got trued up and it just got rounded. Well, now let's assume that it's getting milled right now, and it's squaring those ends back up. It's milling that off, creating those flats and corners again. So and I'm going to move this blue line And I'm going to move this blue line out of my way. Those are my drive rails for something different. But if I draw a line from point A to point B here, and I draw a line from point A to point B here, and I draw a line from here to here, and here to here, I'm going to be using a tool that's called a two-rail sweep tool. A two-rail sweep tool has me select my drive rails, making sure they are both traveling in the same direction. Then it has me choose my profile, and it's going to sweep that profile along that part. And then we're going to do the same thing here. We're going to select these two lines. That's going to be our drive rails. And then our profile, we're going to select that to sweep it across there as well. And then with that model created, when we look at it in the 3D view, we have our two square blanks. Okay, those two square ends and everything. And in the middle, we haven't built that up yet. You know, we've just only, you know, milled that center area and everything. And also there's nothing here in the middle yet. We haven't built any kind of shape or anything. What we're looking at is what's called the zero plane. It's just kind of a flat, no height sheet. When we unwrap this in a flat plane, you'll see those waves, right? Those waves, that's the four corners. And notice that this is a full wave. That's one side. This is a full wave. That's another side. This is a full wave. That's the third side. This is a half. And this is a half, because when they come around, when they wrap around, they become a whole, and that becomes the fourth side, right? So in our preview, this is kind of what it looks like when we're looking at it unwrapped. And then when we wrap it up, it creates those square four sides. And that's how we create a square cut out of our round blank, right? So that's that. All right, now coming back to our 2D view and our design, let's first, before we move on, let's go to File and say Save As. And we'll call this our Rotary fourth axis class. Oh, hold on. I got to close the modeling tool. Got an active model. I can't save it just yet until it's closed off. There we go. Now let's do that again. File, Save As. Okay. Now, before we continue on, we got some questions popping up and stuff like that. Let's see here. Yeah, Izzy's awesome. Cool. I'm glad somebody's got to see him last night. Ronnie said, yeah, I think finished making a double urn. It was all engraved with a male and female quarter included. So you guys are having a conversation. Wonderful. Awesome. Awesome. Conversation going on between everybody. Great. I love when y'all talk with each other. Let's see here. Ronnie says, Laney, what is the largest diameter you can turn on the rotary axis? And can you apply a rotary axis to the new DWC 2636? Thanks. Yes. So on the 2440, well, let's just real quick, we'll run through it all. On the 1824 mini carver, we have a rotary axis that will do about 18 inches long, 17.5 to 18 inches long, 3 inches in diameter. On the 2440, 37 inches long by 8 inches in diameter. And on the 2636, 3648, 4848, and 5100, depending on which way those are mounted, because you can mount them along the X or the Y, as long as you use the appropriate post-processor, which we're going to talk about in a minute. You can mount it either way. So the length is kind of just, depending on your carving area, but also about 8 inches in diameter by default. But if I elevate the center point of the 4th axis on those 4 machines, I can elevate that up to raise that center height. Let's say I raise it up from a 4-inch center to a 5-inch center, then I could do 10 inches in diameter, right? So I just have to elevate to get that extra height all the way around. And I can do that with the 26, 36, 36, 36, 48, 48, and 5100. So good question, Ron, or John, Robert, Ronnie. All right, let's see here. Don't forget to hit the like button. Absolutely. Thanks, Harvey. Okay, so now on this rotary, let's take a look at our reference image again. And so we have some curves and coves and contours, and then we have kind of this weaved area, right? And everything. So indulge with me while I draw out the profile of kind of the shape that I want to, take on here. Now, in about a minute and a half from now, I'm going to be technical and start talking about CAD machining versus conversational machining and things like that. I don't want to lose you. Stick with me. This is kind of cool stuff to know and learn. But right now, I am creating a 3D model, meaning that my 1/8 inch ball nose, 1/4 inch ball nose, 16th inch, whatever it may be, my 1 bit is carving that model, all the highs and lows, ups and downs. It's that 1 bit. I'm CAD machining, computer design machining. I'm 3D model machining. Now, there's also a method of what's called conversational machining or conversational CAM, to where I could use a special router bit that has a special profile, an ornamental profile in some way, and I could just draw a line and have that bit cut along that line to create a specific design. And let's look at ornamental router bits on Google, and let's look at specific. We'll go Magnate. They've got a good selection of ornamental router bits, and if we look at the results of the Magnate ornamental router bits, they have rope bits, spiral twist bits, horizontal crown bits, triple classic, bits, barley twist. They have classical points. They have all of these ornamental type router bits and shapes and all. And if I was using a router bit with that specific contour or shape, then I would just need to draw the path. I wouldn't need to do any modeling at all. Wouldn't need to build a model at all. I just need to draw a line or a path where that bit needs to cut. I need to run a profile toolpath with the bit centered on that line, and I need to specify a depth of cut for that bit to come down and create whatever shape that it's going to be creating. And it's going to just, that bit's going to come in, it'll probably make, multiple passes, but it's just going to follow that one path, that one line or whatever. And when it's all said and done, I'll end up with, a decorative design or something, depending on what it may be, right? and everything. And so the the method of using a specific ornamental mill bit and following a path, that is a conversational machining method. I mean, in a conversational machining application, which hopefully one day Digital Woodcarver will have that option. We'll be working with, if all goes well, with a company, possibly Kipware, that will be offering conversational software. But I have to fill in the blanks. I have to say, where does it start? Where does this cut start? Where does it end? How deep does it need to go? And answer a few questions about my bit, and like the pass step, the RPMs, feed rate, all that stuff. And then it'll generate a toolpath to have that bit follow that path, right? Or cut from here to there, or, you know, it'll follow the instructions that I gave it, right? And the benefits of that, using a specific bit to cut, is time. So Legacy CNC did a time test on doing a table leg that was all 3D model carve, all ornamental 3D modeling and everything. And then they did the same leg, but the portions of it where they could use a specific bit to cut that same design, and then the portion of it where they needed to use the Vectric software to do the model part, like a set of leaves or grapes or what have you. They drew a vector. Let's say that this end part was my vector, and this, I created my 3D rough, my 3D finish, and my model for my toolpath. But the rest of the table leg, I could use a specific bit to do the twist and wrap around and the cove and all that stuff. So they did a time test, you know, and when the whole leg was modeled in Vectric software, and you have your one small ball nose, but you have your rough cut done, and but that finish cut, that small bit, that part is turning as that bit is traveling, you know, cutting, turning and cutting and everything, you know, cruising along, nothing, you know, no speeds and all. But the carving of that table leg as a CAD machined part was 7.5 hours. Taking the same table leg and only isolating the small part that really needed to be 3D modeled, and then the rest of the leg that could use specific bits, end mills, V bits, you know, whatever shape bits they had to do the special shapes and the tapers and things, it turned that entire carve into a 37-minute carve instead of a 7-hour carve, right? And if I'm doing production and I need to make, you know, 100 table legs, and time is money, I can't machine those table legs and be profitable at 7 hours per leg like I can at 37 minutes per leg, right? And so there's a method called conversational CAM machining where those setups and all. And we're not, you know, everybody that uses Vectric and all that stuff, you may have not heard, if you're just new into CNC, you may have never heard of the term conversational machining or conversational programming or conversational CAM. That's because generally you would only see that in industrial use. It's designed for factory floor programming, where the operator is standing at the machine on this factory floor, and he's punching in numbers, and he's saying how big the bit is and what speed it needs to go and how fast it needs to turn, where it's got to start, where it's got to end. And he's programming in he's answering this little widget, if you will, to create this G code right there on the floor, instead of someone in the office drawing up a design in CAD CAM software and sending out this model for this operator card that he's doing it or she's doing or whatever. It right there on the floor, and it's called conversational machining. And you typically see it in metal machining factories and things like that. Well, it's also available in the woodworking world as well too. But we typically work with CAD CAM, computer design, computer machining software like Vectric. We work with you know, Vectric or Fusion 360 and things like that. And all. So In this instance, I'm going to draw out the profile to build the model, but I could also just draw out paths and have a specific bit cut out that same design, right? So that's all I'm saying. So if you're curious about it, you can look more into conversational CAM machining. And who knows? I put a little bug in Vectric's ear during a woodworking show recently. I went and got to spend some time with them at the booth and introduced them to conversational machining. They'd never, heard of it before and all. And they said, interesting. We could look at that, and it could be a gadget or something like that and all. So hopefully, I'm going to stay on them. I'm going to stay on them to, I'd love to see them release a conversational gadget for certain tasks. Now, it does certain tasks. If there's a certain thing you want to do, it's like answering a widget. You fill in the blanks and it creates a toolpath just for that task, right? So it's very specific. It's very limited on what it can do, but it does a lot, it's just a nice way to program. So hopefully Vectric follows through with that. And I'm going to stay on top of them because they were intrigued. They were very intrigued. All right. So now in this area here, I'm going to draw out a boundary. Let's go about there. And I'm going to draw a line from this guideline straight across to this guideline. And I'm going to take and select this boundary first, this rectangle that I just drew. I'm going to hold down the Shift key and select this line last. And I want to align left to right to that last item. I'm just going to center it on that line, right? Center it on that line. Give me 1 second. I'm going to reach up over my head and see if I can get some airflow in this room, office, what have you. Woo, brutal. All right. The line served its purpose. I'm going to get it out of there. Don't need it. Now, this boundary here is where we're going to do the weave in just a moment. The weave is going to happen right there. But in the meantime, I need to create the profile that's going to happen here. Now, when you're drawing a profile out for your part, when you're creating a profile to do a 2-rail sweep or anything like that, if you're modeling parts, in a wrap job, the size of your profile is the radius of your finished part, right? So my cylinder, when it's trued up and round, it's 3 7/8. So my profile that I'm about to draw here is half of that. Okay, so on the height, I'm 3.875 divided by 2 equals 1.9375, 1 15/16. The length is going to go from this edge over to here. So I'll just leave it at 3.4 for right now. And I will drag that bad boy over to that line. Get that sized right on there. All right, now I'm going to move this up over here so you can see it. When you're drawing a profile, it's only the 3 sides. The bottom you don't use. So in node editing, we're going to delete that span and get rid of it. It's our profile here. Okay. Now, again, if we look at our reference leg, I'm not going to go exactly like the reference leg and everything, but if we were, we have a bit of a cove coming in the center and the kind of like a round curve, an arch, and a little lip. So let's come in here, and I'm going to come in and let's insert a point right here. And I'm going to take a guideline to help me out with my layout and everything. And I'm going to snap a guideline kind of to the center here. And from the center of that, I'm going to create a relative guide to the right. I'm going to go a 1/2 inch. And to the left, a negative 1/2 inch for a total of a 1 inch right there in the middle. And then close that. And I'm going to take and go back into node editing mode. And I'm going to insert a point there. And I'm going to zoom in. Notice that I missed that mark, right? If I zoom in, now when I was zoomed out, it looked like I was right on it when I put that point. But when I zoom in, I'm off a little bit. So I'm going to zoom in as tight as I can. Then I'm going to drag that point over to that guideline. Very important, you know, like when you're far out, like if you're working way out here and everything, and you're trying to, you know, create, you know, things and all, it might look like one thing, but when you actually get up to it, I'm off my line, right? So I actually need to bring that point over to my guideline. So don't hesitate to get like right up on it. You know, when you're drawing and designing, zoom in, zoom out, do whatever you need to be able to see and work with what you're working with and everything. So this is going to be an arc, and it's going to be an arc down. We're going to go right a full 180. There we go. And then over here, I want to start kind of, start creating my bead. So I'm going to take a circle and just on this corner here, I'm going to come right there. And just right here. Now, these two circles, I'm going to take a line. I'm going to draw a line like right straight up the middle right here. And I'm going to take these two shapes. I'm going to hold down the shift key and draw or click that line. So let's select those two shapes and then select that line. Let me turn off the guide so I can, so there we go. This shape, before I do that, this shape needs to back up a little bit right about there. Okay. I'm going to take those two shapes. I'm going to hold down the shift key. I'm going to select that line last. I'm going to use the mirror tool to create a mirror copy, and I'm going to flip it about that line. Okay. All right. All right. Now that part says that I'm not centered. Let's find out why. If I come in here and drag a line from here to here straight across, and I double click on that line, my center is right there. I do not know how I ended up right here. Easy fix, easy peasy. Let's go ahead and move these down where they need to be. They need to actually be moved over to the left a little bit. I'm going to go into node editing mode. I do not know how I got off like that, but we're going to cut the vector on that cove right there, and we're going to cut it over here. And I'm going to select those three vectors, that line, because that line is center of that cove. It's just the cove's not centered. And I'm going to come in and I'll actually just grab it right here. And I'm going to drag it across my line until I get to the center of my line. And then I'm going to come in and extend this out. Oh, there we go. Now I'm going to take my scissors and I'm going to trim that excess away. Zoom right on into there. We'll just trim that away. I'm going to come over here and trim that away and zoom in a little bit tighter and trim that away. And then I'm going to come over and I'm going to select these two circles and I'm going to delete them. And once again, I'm going to select these two circles. I'm going to hold down the shift key, select that line last, and I'm going to mirror, flipping about that line. So I end up in the same spot. There we go. Now we're cooking with some fuel. All right. Now over here on this corner and everything, I'm going to use my fillet tool. And I'm going to go with a 3/16" radius there and right there. I'm going to take my scissors and I'm going to trim this line away there. Trim that line away there. I don't need that center line anymore. I'll just delete that. I won't trim it and all. This is going to get cut here. Actually, that was a lie. It's going to get cut there and from the bottom. And then in node editing mode, this line right here in the middle, I'm going to right click and turn it into an arc. I'm going to turn this one into an arc. And then I'm going to get rid of that center line. I'm going to get rid of that horizontal line. And that's going to be my part. It's a funky looking shape, but that's what it's going to be. What I'd actually I'd like a little bit more meat here. So I'm going to draw a line straight across. I'm going to take my shape here and I'm actually going to bump it up. Not that shape. Bump that back down. I'm going to take my arc right here and I'm going to cut it free, the arc. And I'm going to take that arc and I'm going to bump it up. Make sure that's an arc. There we go. Perfect. All right, now I'm going to just trim that back. And I just wanted a little bit more meat right there and right there. I'm happy with that. I'm good with that. All right, that is my profile. That part right there is my profile. And that's the shape that I need to run this way, vertically. So here I'm going to draw sweep lines, okay? And so I'm going to draw a line. Even though I have a rectangle here, that boundary is for something else. I'm not going to use it. So here I'm going to draw a line from point A to point B. And I'm going to select that line. I'm going to hold down my control key. Control key makes a copy. And when I drag off a copy of that line, let me grab it, drag a copy. I'm going to snap that right over here on that right side. Now, what my key is to make sure that my line is slightly overlapping that model a little bit. I want it to blend. I don't want a big old like slice in the middle. All right. 2 rail sweep. I'm going to take this object right here. It's going to probably be matching over here as well. So that one shape, I'm going to hold down my shift key. I'm going to select my left drive rail first, my right drive rail last, and that's going to be my selection. Then I'm going to drag my profile. Now notice that that's not connected. Can't have that. So let's close that for a minute. It's got to be one vector. So let's click this and join into one open vector. All right, one more time. 2 rail sweep. Left line, drive rail. Right drive rail. That's my selection. Make sure those arrowheads are facing the same direction. Make sure they're not going backwards, from each other. It'll twist that model that it's going to create. They got to be going in the same direction. I don't care if it's up or down. They just got to be traveling in the same direction. We're going to take our profile there and we're going to sweep it between those 2 lines and click apply. Okay. And then when we go into our 3D view, we should see a part that looks like this. And then when we wrap her up, it should look like that. Okay. Okie dokie dokie. All right. Now over here on the right side, I should be able to close that tool. Now I don't have to really sweep another. I don't have to do another sweep and all that stuff. If this is truly centered, then this width and this width are the same. So I can just take this component that I just created. And what I'll do is I'll draw a line. It doesn't really matter where. Let's stay in the center, but though. Draw a line there. And I can take that part. I can hold down. I can grab it kind of like right in the middle. I'll center it and all that and stuff in a minute, but I can hold down the control key and I can drag a copy over to there and get that centered, but I need to center it up and down. So I'll use my alignment tool to up and down on the material. Get that centered there. And just a bit off. Wonderful. Okay, so now if we look, we have that part. Okay, so this is getting somewhere. Now the fun part is the weave in the middle, right? The weave in the middle. Now, for the weave, we're going to create a grid. Now on this grid, now let me just talk about this. First of all, on the weave, we can have this weave going straight across and up and down like a weaved basket. We can have it going at a 45 degree. We can have it going at a wiggly line. We can have it going any way that we want. Now in the drawing here, the weave is going over and under, and it's going at a 45 degree, but kind of like how this pattern is and everything, how this pattern's happening, there is a little bit of a kind of a twist going on there. Now, my weave, the height of my weaves and everything, they're going to be 1 inch wide, 1 inch wide, and the weave itself, the shape, not the base, right? The shape is going to be probably about 3/8 to 1/2 inch thick, right? So the first thing I want to do is draw out one of those pieces. So we're going to go 1 inch and then 0.5. And that square represents one of my strands, right? The shape of one of my strands. Well, what I want to do is, remember, in node editing, when we're creating a profile, we don't use the bottom line. So we get rid of that. Don't cut the vector. We get rid of that span, delete the span, get rid of it going. Now, I'd like a little bit of a radius on my weave on the edges of this. I don't want it to be just square. I'd like a little bit of a flow to this. So I'm going to use my fillet tool. And I like a 3/16 on this 1 inch weave. I like a 3/16 inch radius. So that's what I'm going to go with and everything there. Now I have basically a shape of what I want. Now I need a path for that shape to follow. Now on the grid, let's start out with one line. Okay, let's start out with one line here. And I'm going to create imagine, if you will, let's just focus on one line for a second. If I were to take my shape and center it on that line, right? From one weave to the next and everything, I'd like to have a little bit of space. I don't want them, I could either have them like right on top of each other, which is kind of like what that leg, they're right on top of each other. Or I can have a little bit of space in between them to kind of almost give it that little bit like a weave basket look or what have you. So if this is 1 inch overall width on my shape, then if I want this part, if I come over here, do I want the next weave to be just right on it, to where I have this little bit of an indentation in between, or do I want a little bit of space in between the weaves, right? I gotta kind of know this, because that tells me how far apart that I need to, space my lines, right? From center to center, if you will. If it was just where these were butting up against each other and I'm at the halfway mark on this 1 inch piece, then I would have a 1/2 inch space in between each line, right? A 1/2 inch to here and a 1/2 inch, so 1 inch space between each line. So when I'm creating my array of lines, I'm going to have one row, because I'm going up and down with this line, and I'm going to have, let's say, 15 columns will do. I'll delete what I don't need. I could say I want that space going along my X to be 1 inch apart. And if I do that, then my weave is going to be like right on each other, right? No space in between. If I said, okay, I want a 1/16 of an inch of space in between, a 32nd on this side and a 32nd on that side, if you will, right? Then the space between my lines, I would be from here to here, I would be that 1/2 inch plus that 32nd. And then from here to here, that 1/2 inch plus that 32nd to equal that 1 1/16, right? So I could go 1.0625. And when I copy that line across, 15 lines across, right? It creates that. Now, one of those lines got duplicated right there. But let's get rid of that part. And over here, my lines keep going, right? I made 15 of them. I do not need these lines over here on the right. I can get rid of them. And these lines in between here, I want to center inside of my little outline, my rectangular outline. So I'm going to select those and I'm going to group them together. And then I'm going to select my rectangle and I'm going to align them to the center of that last item, that rectangle. So I'm going to shift them over. So now they're centered. Okay. my shape. I can move that up there. Now, I'm going to take this set of lines here, and I'm going to make a copy of it. Control-C, Control-V, copy and paste. All right. So what I want to do is I want to select these lines. Let's close our alignment tool. I want to Control-C to copy, Control-V to paste. Now the new copies are selected, not the old ones. The new ones are. So now I can hit the number 9 on my keyboard, which is a 45-degree rotation counterclockwise. And I can hit it once, twice, 3 times. There you go. Right. So to make that grid, Now on this grid, on these horizontal lines, I'm actually going to stretch them out. I'm holding my shift key so that when I stretch these out to this line, it does the same thing on the other side too. The shift kept it centered and stretched it out evenly on both ends when I was pulling that one side. So now I have a grid here that I can have my shape follow. Now here's the cool tool that's going to create the weave. So if I go into my single rail sweep tool, my center line sweep tool, extrude and weave it's called, I can select my grid lines and I can use them as my selection. You're going to see I have the grid, right? So I got lines going horizontal, but all my horizontal lines, all the arrows are pointing in the right, one direction, not the right direction. They could be pointing left or right, but they all need to be pointing in the same direction. And my vertical lines, the arrows on the vertical lines are all pointing in the same direction. That's good. That's what we want. And so now, with that being my selection, I can select my profile here. And I'm going to use that cross section. This is called a cross section that I drew. And I'm going to sweep it between the spans, not between spans, but on the lines. Okay. And I'm going to weave those parts wherever there's an intersection, wherever there's a crossing. I want that to weave over and under. And I have options. I can go under by 70% of my shape, over by a certain percentage. And in this case, I'm going under. On the Z, I'm reducing it by 70%. So 30% will be, left on 100%. And on this one, that 30%, I'm going, on the over. Okay. So I've kind of just taken 30% from here and added it to there. Now I'm going to merge these in. I want it to be a merge because they have to merge with the two models on the side. It's got to blend with the models on the side. Now, when I click apply and create this shape or this weave, if you will, what you're going to see is I should end up with this kind of 16 by 16 inch little white square in the middle, right? And that's the gap between this one and this one on the grid lines. That's, when those parts come in, the top part and the bottom part and the two side parts, it's going to leave me with that little square, that little gap. Now, if I look at this in the 3D view, okay, we have this weave going on here. But notice the weave is small. Notice the weave is small, and it's not as big as it should be on the diameter, right? And the reason for that is because my parts were only 3/8 of an inch tall or a ½ inch tall, and it needs to be 1.9, whatever it is, half my radius, right, of my 3 7/8. So when I come in here and I close this out, if I unwrap this for a moment, you can see that I need to elevate that part, the base meat of this model, right? I don't want to change my shape height. I don't want to make my shapes all funky and tall. I want to just add some meat underneath. that part to elevate it. So when I go into my component tree, that last component that I created here, and all these components need to be a merge. So bear with me just 1 second. I need these to blend together. I need them to play nice with each other. So I need to select this one, change the combine mode to merge. That one, change it to merge. I need them to blend and play nice together. I don't need them to be stuck with each other. So merge. Two more. And merge. Merge, merge, merge. Okay, that's good for now. All right, this component here, this weave that I just created, if I go into its properties, I have a shape height and I have a base height. Now, my shape height is 0.65 inches tall. So basically, my 1/2 inch tall weave band, if you will, when it wrapped over the other weave by that 30%, it added that 0.15 inches of height to that part, right? So the overall height is 0.65 instead of 0.5, right? Because of that hump on that wrap, right? When it wraps around that hump right there, when it's wrapping over, it added that 0.15. And that's fine. That's fine. But I need to give it some base height. I need to elevate the base height. So if I take my radius, right? My radius, which my diameter is 3.875. If I divide that by 2, that gives me my radius, 1 15/16. I need to subtract my shape height from that. So I need to come in here with that 1 15/16 and subtract the 0.65 to give me the height, so that I'm just about right at the level of this part there. Wonderful. And then on my part here, I need it to blend with the models on the side and everything. If I paid very close attention to the models, I could see, you might be able to see it on the screen. You see that kind of like white dotted line right here down the side? If I were to zoom into that and really, really zoom into that, that is a void going down the full length of my part. Those two pieces are separated by that small amount, but there's a void there, right? Now, sitting here looking at this, if I, have nothing selected, with the shadow shading and everything, I can't really see a void there. When I'm close up to it, I have no clue that there's a void there. And probably when it carves, since it's so small, the bit's radius of the tip of the bit is just going to pass right over that. It's not going to go down into it or anything like that. But you never know with toolpaths and everything. So that split, when I zoom in a little bit, you can now see the darkening of it right there, right? I need that gone, right? So I need this weave to kind of blend into this part over here. So what I need to do is I actually need to come in here and I need to click on my weave part. I'm going to not use, I got the weave created already, so I'm not going to try to scale my whole grid, right? My whole grid and all that. But what I'm going to do is I'm going to take my model, and if I look, I can see there's a white gap right in between there. You see that white gap right there? That's that gap. But I'm going to take my model and I'm going to pull it out into that part. Okay. Now, we're going to talk about these holes in just a minute. We're going to talk about those holes in just a minute and everything, because that is a void going all the way through my part, like a hole like a hole going all the way through. We're going to fix that in just a second. Now over here, I want to, if I zoom in, you can see that white gap right here. If I pull that, I want to pull that over to kind of cross over the line, right? Just getting a little bit of a blend, you know, to kind of avoid that together, and everything. Now, how no? We have this rectangle vector, this rectangular vector. Okay, that what I used for kind of the perimeter. I'm going to also use that rectangle to create a blank that has a certain height to it to fill in. I still want this, I want that weave to have that kind of like the space in between the weaves, but I don't want it to be like actual holes, like a sprinkler system, you know, in my leg and all. So I need to put some meat underneath it, right? So I'm going to take my rectangle, or my square, rectangle, it's rectangle. I'm going to take my rectangle and I'm going to go into the design tab and I'm going to create a flat shape. And the height of that flat shape, now remember, my part of my weave, the shape height was 0.1625, or I'm sorry, 0.65, sorry, 0.65. And then my base that I put under it to raise it up made it a different height now. So let's, before I add that piece of wood in there, let's turn that off for a second and let's look at my components real quick. My height of this part, the weave, is 0.1289 plus 0.6507. Let's do some calculator math here because it's been a long night. Let's see here. Let's go 0.6507 plus 1.289 equals 1.9397. Now, Laney, 3 seconds ago, your part was 0.65. Where did the 0.07 come from? Why did it change? Well, when you stretch a model, bigger or smaller or whatever, not only does it change the X and the Y, but it also changes the Z. So when I slid and stretched it over on the left and I slid and stretched it over on the right, it was actually changing the left, right, but it was also making the model slightly bigger as well, too. So that's where that 0.007 came from. Okay, 0007. That's where that came from. Now, if I say, okay, hey, let's, if I'm at 1.9397, all right, let me see here. If I subtract 1.9375, that's 0.0022. I'm going to actually I'm going to skim a little off the base. Let's skim a little off the base. Minus 0.0022 equals. And now my part is going to be, if I clear this out, let's do the math. 0.6507 plus 1.2868 equals 1.9375, right? So 1.9375 is the overall height of my shape, right? My top part, the weave part, this is important. The weave part is 6.6507, and the base, the straight meat under that weave, is 1.2868. Now, technically, depending on how deep I want my little holes to be, I could create another shape, that flat shape that we were about to do 15 seconds ago, at this height, 1.2868. Or I could take my overall height and subtract how much down I want, to be underneath, and how deep do I want those holes, and I could do the math that way. Well, in this case, I'm going to make it simple. I'm going to copy this value, the base height value here, and I'm going to go back and select my rectangle. I'm going to go into the design and create a flat shape that tall. Paste. Now that shape is going to merge with the rest of my model. It's going to merge. Wait for it. Wait for it. And then I'm going to click apply or create, not apply, or create. Okay. All righty. Now, let's look at the 3D view. Okay. And so on my shape, if I turn this out and I zoom in, I've filled the void. Now, just to show you, right? If I were to go any higher, let me copy this number, Control C. If I were to go any higher, let's say I was at 1.5, right? And I click apply on that part, we should start to see it poke up through these holes when it creates that piece. So give it a second. Okay. And let's go up a little bit higher. So that's 1.79. Let it regenerate. It's a little blurry. You see that part, right? It's in that weave there. I don't want to go that high. That destroys my weave. But what I'm doing is I'm filling in underneath. I'm just showing you that it's filling in underneath, right? So what I want to come in here to that height that I had. Let's paste that number back in there and click apply, right? So I'm just at the base of my weave. I'm just at the base of the weave and everything. So let that regenerate. I'm just basically, I filled in the holes, right, with that shape. So it's going to take a second. There we go. All right, let's close this tool. Let's come over here. Now, let's turn off the guidelines. All right. Zooming in between my little cove parts and the ends, those square ends and everything, kind of really zooming in, looking at the shades and the shadows and all. I have this white void right there. And that is technically a void between the two parts. Right? Okay. Okay. All right. All right. All right. Got a good overlap there. On this part here, I'm gonna just ever so slightly pull that over. Now it's set to merge, so it's just gonna blend right in. And I'm gonna do the same thing on this side. Zoom, 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 zoom. And I'm literally just pulling just to merge. Now that part, I don't want to merge too greatly, right? I just want a little bit of merge, and it's not going to affect the overall look of my design because I'm literally just blending that part, those two parts together, and it's so minuscule. I'm just blending those two parts and all. So now if we look at our table leg in a flat plane, this is what we have just created, right? And those ends with those points and coves, those corners, looks odd. But when we wrap it up and we end up with our leg, our large diameter leg here. Okay. Now, hold the phone, Lenny. I thought you wanted to maybe put a little style to that weave, a little bit of an angle and not so straight and everything. All right, let's spend just a quick couple minutes and let's fix that. We're going to take our grid that we create, not our lines. Those were made, those were used to make the part. I'm going to leave them as they are, but the part itself, my grid part, this part right here, I am going to rotate that. Wait for it. All right, all right. Now, I got some voids here, 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 and here. It's okay. I'm going to end up kind of stretching my part. Okay. So I'm going to hold down the shift key to keep it centered, and I'm going to scale the part up. Now, when I scale this up like this, I'm not only scaling, keep this in mind, this is important. I'm not only scaling the X and Y, but I'm also scaling the Z. So I need to make sure I go back and fix that. I need to make sure I go back and fix that after I'm done doing what I'm about to do. What I'm about to do is I've got this stretched out to just where I'm right outside of my square, my rectangle, that outline. Okay. And I'm going to come in here and I'm going to hold down the shift key and I'm going to select on that rectangle. Wait for it. And I'm going to go into my modeling tools and I'm going to click a button that says clear the area outside of the model. Clear the model outside of the selected vector, meaning delete it. So when I hit this button, it's going to delete everything outside of that rectangle. Okay. Okay. And it's going to bring it back down within my design, right? Now, I need to go into that component and I need to go into the properties of it and fix my height because I stretched it. I stretched it and everything. Now you can see right here, right? It's much bigger than what it was, right? So I need to fix it. My shape height is going to be 0.65. Oops. .6507. And my base height is going to be 1.2868, what it was originally. All right, all right, all right. Now, going into the 3D view, let's unwrap this for a second. Take a look at it. We now have this diagonal pattern. All right. Now, that 0.65 on my shape height, I'm good with that, but I'd like it to not be over this cove right here. I'd like these little humps not to be there. Just doesn't look good. So I'm actually going to come in and lower, almost kind of like flattening the part a little bit. I'm going to take this down to 0.625. Let it regenerate. I'm going to watch. I'm watching these ends here and everything to see if I'm reducing stuff. And then I'm going to take a little bit off my, let's go 0.275. All right, we can go a little bit more. Let's go 0.215. Now we're getting somewhere. All right, I'm going to take a little bit more off the height up here. So we're going to go 0.5625, 9/16. And that should bring me just under that lip. So if I turn this a little bit so I can see, I should be just under that lip right there. And I'm good with that. All right, all right. Same thing on the other side. Wonderful. Let's wrap this back up. That's my diagonal weave there. Wrap it up. And that's my part. Now, on here, I'm going to switch this to top, right? Let me flip it around. Or bottom. You see that seam right there? And everything, that seam? When it comes to a weave and everything like that, it's going to be very hard, especially at a diagonal angle, to get the things on the front side and the back side to like be perfectly lined up and stuff like that. It's going to be, you know, somewhat close, but it's not going to be exact. The only way to really make it exact is to stretch the part out so that this shape right here and this shape right here were to overlap each other, like in the same location, to try to, you know, clean that up. But the just know that there is going to be, in a sense, because we're wrapping and everything. Now, when you sand, it'll sand, you know, away and all that stuff, but it's not going to, it's not going to flow like the rest of it. There's going to be one little part where it looks a little odd and all, and that's the part that you always have facing in or facing away that's not facing out where everybody can see in, blah, blah, blah. All right, now, looking at this part here and everything, in the new version 12 of the Vectric software, it looks, you know, big and beefy, right? I want to make sure that if I go into my material setup, that I'm not exceeding my material thickness, right? The part is larger on the radius. It's larger than what the radius is of my part, you know, on my 3 7/8. That's why it looks so bulky and big. And also I can tell by the green kind of outline here that, you know, I've exceeded my part. Now, what has exceeded the part, ladies and gentlemen, on that thickness and everything is the corners, right? The corners are, you know, much taller and all. So it's the part itself. You can see this green, the green lines kind of represent the boundary of my 3 7/8 piece, right? So this part is kind of much bigger, right? So my model thickness should be 1.9375, but it's 2.7375. So I should be able to just go right into here in my model thickness and change the overall height, or one by one, I go in and remove some of the height off of my model components to bring everything down, you know, that way. But I'm going to do it as a whole. As a whole, I'm going to make my radius 1.9375. And now my part fits. It doesn't look so fat and bulky as well, but it looks more like a 3 and 7/8 piece versus a 6 and 7/8. But it fits now within my stock. That green outline represents my stock and everything. And so that was my final step. And what we have created is this part here. Pretty cool design. All right. Let's go ahead and hit save. And then let's go over and let's see what kind of questions we have here. Is Lainey freezing up to anyone else? JR, did I freeze up to quite a lot of you? Let me know. YouTube is messing with me when I had my VPN enabled. Yeah, VPN, I don't have very good luck with VPN and YouTube sometimes. I'm not on a VPN right now. Oh, I shouldn't say that out loud. The hackers are probably listening. Shh, I'm on a VPN. All right, let's see here. Okay, Lainey, this looks great. How would you taper the leg to a smaller foot? Well, you would create that tapered drawing. So let's take my lines there to there. Let me take this. We'll move it over here so we can see. We need to hold down the control key and drag a copy here. And let's do it in square form first, so you can kind of get the idea. So this represents this shape here, which would be the top of the leg there. And so let's say I want to taper down to this, right? If I unwrap this, that creates this shape here. So we can get rid of this one. So I would be going from here to here. And so on my 2-rail sweep, I would select my vectors, my drive rails. Let's go in and go into our components, and let's turn off that component right there. And I would select my drive rails. I would go into the 2-rail sweep tool. Those are my drive rails. Okay. Now I'm going to select the profile here. And that profile, notice the line here, right? And I'm starting from here on this. But now when I come in and I select this profile, I can come in and I can say, I need this one right here to go to here. Okay. So to assign that red color from there to there, but I need this one at the top. Okay. So I'm going from this yellow profile, this one, to the red profile, this one. I'm tapering down to that. And when I create that part, it creates that taper. Now I need to merge it, not add it. So that you see that sprawl that's out here, this sprawl and everything, that's because the part is set to an add, not a merge. So let me go back into my component tree and change that part to a merge to blend it in. Okay. And of course, I can take this and make this smaller to where it's a more in line with, this part here, in the middle and all. So my height here doesn't need to be that large square anymore. If I, on this particular height here, this height represents, the height of this square represents the height of my part, right? So if I go back into the part right next to it, and I look at the properties of that component, which have changed now, because remember, everything got scaled. Hey, Kool-Aid, thanks for the super chat, man. All right, money, money, money. Thank you, buddy. I appreciate that. That shape height is 1.4798. 1.4798. So if I come in here and now that's my radius, 1.4798 is my radius, right? So the rectangle that I'm drawing here, let's go into the size tool, represents the full diameter, right? In this case, if I take that 1.9738 and times by 2, that's what that's going to be. But I'm going to go, I want a little bit more meat. So I'm going to go, I'm going to go just that quickly, ladies and gentlemen, just that quickly. I spaced out 1.4798. I'm going to go 1.5. So on this shape here, I'm going to go change that to 3 inches, right? I'm going to take this, delete it, gone. I'm going to take this, unwrap it. I'm going to take that new shape, pop it there. I'm going to take this shape, delete it, gone. And I'm going to do it again. I'm going to take this drive rail, hold down the shift key, take that drive rail, and go into the 2-rail sweep tool and select this profile first. Now, I'm going to select this profile. First of all, let me do the lines first, drive rails first. This and this. Use that as my selection. Now, when I select this profile, I'm going to come right back to this green node and click on it, right? And it's going to assign that red color to that profile. Now, I'm going to select this profile because I'm going from that to this, and I'm going to select this point, and it's going to change it to yellow. So I'm going from there to there. Now, I could do anything. I could do any kind of profile from one point to another, right? And all that stuff. So let's go ahead now and create that part. Let's click apply. Kool-Aid, man. Kool-Aid. Thanks, buddy. Appreciate you. Yep. All right, let's go into our, let's close that tool out. Let's go to our components and make it a merge, not an add. And then let's go into our 3D view. And we have that a more appropriate, size leg if we were tapering into that. right? Yeah. Now, if we look at our reference image of our bar and everything, our island and stuff, what we can see is that they actually have the leg sitting on, an additional base on top of that, right? To give it the height. And, the corner leg is straight down, no taper or anything, but that if you were going to taper, that's how you would taper, just what we just went through, right? But they're, these are straight, no taper, dun, 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 no taper. All right. Let's stand this bad boy up. And there you have it. All right. Now let's talk about one last thing. I'm gonna hit you with one last thing on your mind and all that. Now, depending on your CNC machine and depending on your post processor that you use with your Vectric software, or whatever software, whatever your CAD/CAM software is, and everything, one of two things is going to be happening. Your rotary axis is either going to be, it's going to replace the x-axis. If the length of that spindle was running along your y, the rotation could be the x-axis, or it could be the a. If it was running along the x-axis, that rotation could be your y-axis or your a. Generally, most machines, that rotary axis is, it's either their X or their Y, depending on what's rotation. And it rotates by, inches per minute. And the steps per minute is the point of rotation. It's rotating 1 inch, half inch, 3 inches, or what have you. Now, if it is set up like a true rotary axis where it's the A-axis, your A-axis typically in your controller software runs by steps per degree, 0 to 360, and degrees per minute. Basically, to go from point A to B, when I cut from point A to B, my spindle is going to turn, let's say, from 0 to 45 degrees during that motion, right? And in your software, in the Vectric software, you probably have a post processor that might look something like this, where it says the words wrap X or wrap Y or what have you. And basically, let me hit save on this design. In the post processors, let me see here. You will probably see something along the lines where it takes in this case, I'm wrapping around the x-axis, right? It's oriented along the x. I'm wrapping along the x and everything. And so therefore, it takes all of my y values and it turns them into A values automatically. So when I calculate the toolpath in my post processor, you'll see that your values, you have your X and Z movements, but then there's going to be this A movement in the rotary toolpath, and it's going to be like between 0 and 360 degrees. It's not going to be like, 1 inch, 2 inch, half inch, 3 inch, it's going to be 15 degrees, 30 degrees, 36 degrees, and that kind of thing. So it's going to be based in degrees and stuff. And so there's post-processors that wrap your values around whichever way your machine is, your fourth axis is designed to be orientated on your machine. And it takes whatever those turning values are, X or Y axis, whatever it is, and it turns them to A, degrees and stuff. Now, you might not have a post processor in your Vectric software or for your machine that turns values to A. It might just be a regular standard post processor that just simply, let me get it to bob up here, that just simply puts out, X, Y, and Z values. Regardless of what your post processor puts out on your rotary and all, just make sure, if you've never done, fourth axis or rotary axis or anything like that before, and you're kind of just getting into it, it's like something you've got the attachment for the machine and you're just getting into it and everything, make sure you're using the right post processor so that your part is doing what it's supposed to do, so that the G code that's created is for your machine and your setup. Most all machines will have a regular post processor for when someone's milling on the table, but then they'll sometimes either they use the same regular post processor regardless of if you're carving on the table or the fourth axis. Same post processor does both, like with our 2440. With our 2440, the y-axis, when in fourth axis mode, the rotary, the spinning is the y-axis. It's not the A, it's the Y. Because in this particular instance, our fourth axis is mounted off to the side and the router pivots 90 degrees. So it turns, when it turns, it's the y-axis. So we use the regular post processor, regardless of if the user is carving on their table or if they're carving on their fourth axis. It's the same post processor that does both. But on our mini carver 26, 36, 36, 48, 48, 48, and 5100 models, the rotary axis mounts on the table and the router cuts overhead. And so we still have X, Y, and movement and Z movement of that router. And the rotary is the A axis. It's the true A axis, right? And so what the post processor assumes when it converts one of your letters X or Y to A is that you're centered over your stock and that doesn't move. You only move back and forth along the length of that stock while that stock turns. So if my x-axis moves back and forth along my stock, those are the values that's going to be put out. My z-axis goes up and down to carve the stock. Those values will get put out. But the y-axis, it stays in the center. It doesn't move, but I have rotation. So in Vectric, that movement is the y-axis in this case, but it needs to be converted to A. So it turns all the y values into A values so that rotate turns. And so when you're looking at the post processor, you'll even see, it might say something like, if we look at the post processor, it says here, there are no Y moves output in the G code. The tool is assumed to be aligned with the center of the cylinder. So in the G code, when it creates the G code and the coordinates and everything, there's not going to be a y-axis. There's only going to be X and Z, and there's going to be A. That's 0 to 360 degrees the turning. You will not see a y-axis whatsoever in that G code. And if your fourth axis is turned the other way on the table, where it's running along the Y and the X is the rotation, there will be no x-axis outputs in the G code. It'll only be Y, Z, and A. So it takes all those X values and converts them to A automatically, as long as you're using the right post processor. So if you're just getting the fourth axis, you need to make sure you check with your manufacturer. Is there a particular rotary post processor that I should be using with my machine? If so, where do I access it? Usually Vectric has a whole list of, different machines and their post processors and stuff. Or it's provided when you purchase your machine or all that, or you can download it from your manufacturer's website. And Axiom, you can download it right from the website and a few other places and things like that for their machines and stuff like that. Digital wood carver, you can download it from our website and stuff like that. But just make sure that you're using the correct if you're just, this is my last little note, just make sure that if you are doing a rotary job and your rotary axis is programmed to your control board to be A, not Y or X or whatever, it's plugged into the A port and the A driver on the brain, right? Then you need your G code to spit out A values, right? So it has to turn one of those values into that A. Otherwise, it's not going to move properly, right? It's not going to do properly. So just make sure that you're using the correct post processor for your machine, for your controller, and all that stuff. Okay. All right. And Wade Constance says, and be ready to hit the e-stop on your first attempt. That's true. I tell you. Now, the last little anecdote or funny thing with me is on the 2440, which is the machine I kind of grew up on, right? It's the first machine that I had. The rotary axis is mounted to the side and the router pivots 90 degrees, right? And when the router pivots 90 degrees, it moves over and it carves as this rotates, as the fourth axis rotates. Well, when the router is in its upright position, we have X and Y and Z, right? Or X, Y, Z, whatever, just that back and forth and everything. Well, when the router pivots 90 degrees on the 2440, the Y-axis movement is now the Z-axis. The tip of that bit is moving towards the stock over here, so it's going in and out. So that Y-axis movement is Z. The A-axis, which is the rotary axis, is Y, the rotation. X is still the same. Z is still the same. And A is when the bit is centered up and down on the stock, right? The Z becomes the A, up and down. And that was my most complicated thing on the first go around, was wrapping my head around the axis change, right? The letter change and, what axis is what, this is now Z, because going to your stock and from your stock is your Z axis movement, regardless of if I'm on the table or if I'm on the rotary axis, right? It's still the Z axis in and out. So, but it's traveling on a different motor now. When I'm in fourth axis mode, there's a different setting and everything and it travels along that Y-axis rods to go to the stock that's mounted on the side. Now, for machines where the rotary axis is mounted on the table, the router's over the stock. So nothing changes. X is X, Y is Y, Z is Z, A is A, nothing changes. But when there's a shift and the part is mounted to the side, and like the 2040, there's an axis change, the letters change. And it was like my first couple of times, it took me like two to three times to get just really wrap my head around it, back in the day when I was just getting started. And so I was definitely on the e-stop. Wait, I was definitely ready to go with that when I was hitting start, but it was pretty good. So all in all, my biggest concern was, making sure I had the right pass depth and I wasn't eating too much out of the rough cut and all that stuff. All right, ladies and gentlemen, well, listen, make sure you're using the right post processor. Play around with making models if you have the Aspire software, making your table legs. If you don't have the Aspire software, it's not the end of the world. You can still do rotary axis things using the toolpath in the software of the molding toolpath. You can create a molding profile of a spindle or leg or something. You can still V-carve. You can still do a rounding toolpath and V-carve designs in that rounded stock to make like cookie cutters and rolling pins and all kinds of fun stuff. You can import 3D models of table legs and spindles and statues and stuff to carve on the rotary axis. So just because you can't build a model specifically like we did from scratch here tonight doesn't mean that you can't use a fourth axis. You can use a fourth axis with your Pro or Aspire software. Now, the reason why I'm not including desktop in there is because desktop doesn't have access to the gadget library and the wrapping toolpath for the rounding toolpath. But I could still bring in a table leg on my mini carver with my desktop software. I just have to create kind of a manual milling toolpath to mill off my corners and round up my stock a little bit differently. I can't use the gadget because in desktop, I don't have access to the gadget, right, to do that. So a little bit of a workaround required if I have desktop, but I could still do it. You know, it just takes a few extra steps. Pro has access to the gadget library, so I can do the rounding with it. Aspire, of course, has access to that. Pro can't build models, but I can still import table legs or do molding toolpaths or V-carves or whatever. I can use my clip art to help kind of build things. So I'm not, you know, I can't, you know, I can still, you know, use my fourth axis with Pro. Aspire just gives me that a little bit of freedom to create my own custom table leg like we did tonight. And in that instance and things, right? All right, everybody. Well, listen, thanks, John Thompson. I appreciate that. And once again, Kool-Aid, man, thanks for that super chat. That $10 is going to help me out a lot. I appreciate you very much for that. And for those of you that don't know what super chat is, it's just a nice way to buy me a beer, if you will. Not really. I don't drink, but you know, it's a nice way to kind of tip or you know, throw an extra bonus if you think that there's some value in the information that you're receiving from the lesson. There's a little $sign right where you type in your text for your, you know, when you're sending chat messages. There's a little icon there that you can send a super chat. So that's what that is. All right, everybody. Well, listen, y'all have a wonderful evening. Hopefully this was something. We're going to go into it more because back in version 10, I think it was 10 or 10.5, Vectric introduced inverse time mode, which you generally see that G93 inverse time mode. You generally see that with rotary jobs. And basically, instead of a you know, inch per minute rotation and all, it's based on a distance per minute or a speed per minute, not a distance, sorry, a speed per minute. I want to get from point A to point B in 60 seconds. By the time the move completes, it needs to be 60 seconds. And that inverse time basically sets up to where when this is rotating and cutting, by the time I get to that endpoint, 60 seconds has passed, right? So inverse time mode, it's kind of it's based on time. The movements are based on not distance and inches per minute. It's the time, you know, per distance, you know, the per time, and degrees per minute and all that stuff. So we're going to talk more about that in kind of the next phase. This was kind of like let's call it, even though I've done rotary jobs in the past, let's call this one kind of a getting started in rotary, just talking about, you know, some different things in post-processors and all. And then next time around, we'll see if your post-processors have inverse time mode set up, if they're, you know, if your machine allows for that. We'll talk about what inverse time mode is and why it's used, when it's used, and what it looks like and stuff. And we'll continue on with talking more and more about fourth axis as we go on from time to time. So keep an eye out for those if that's something that interests you. Until next time, I'll see you soon. Thanks, everybody.